in speed and or capacity every 18 months. And if you put that together with some fundamental breakthroughs on the technology side, virtualization as a core enabler, things like HTML5 as a core enabler, we should be expecting an explosion of computing benefit. And I have the pleasure of traveling around the world, talking to CIOs around the world and business leaders around the world. And what I find amazing is with this extraordinary explosion, what should be an extraordinary explosion in feature functionality, dramatically dropping costs, is those things aren't being delivered to the bottom line. If you look at the average IT budget, it continues to creep up with GDP. And still somewhere between 70 and 75% of the typical IT budget is keeping the lights on. And so if you think about that, something's fundamentally broken in that the underlying component parts are literally doubling in performance every 2 years, but the ultimate output that end users are seeing is moving very little. Now, that issue for the typical IT department gets even worse when you add in the fact that the expectations or the demand for IT are exploding. And there are multiple drivers of that explosion. I mean, take the simplest one. CIOs are being driven by expectations of CEOs, CFOs, CMOs, who are now seeing their best technology experience happening at home. People have gotten used to Google and Facebook and Twitter, and the richness of the IT experiences they're getting, the speed with which functionality is being added, is extraordinary. And by the way, those things are all free. So you put it together, the average IT department is seeing an explosion of demand, but it is seeing little change, if anything, slightly creeping underlying costs. So where is that gap? If there are new technologies, if the underlying cost of the infrastructure is collapsing, if you have new technologies that are bringing delivery models like cloud to the end customer, why are costs going up? And I would actually argue there are kind of three major drivers of that, and that Red Hat is in the epicenter of trying to address. First off, the fundamental way that software is developed is broken. Traditional software models cannot keep pace. And let me talk about that in a couple regards. And let me kind of back away from technology for a minute. Yeah, I come from outside the technology industry, so I hope that brings a little bit of a different perspective. And I did a lot of work in manufacturing, obviously, and in logistics when I was at Delta. And what I find amazing is the parallels between open source software and Kaizen, or lean manufacturing, or Toyota Production System. There are a number of names for all basically the same thing, which is a fundamental change that happened in the late 70s and early 80s globally around manufacturing. If you go back to the 1960s and early 70s, most of the world went through it, or most of the manufacturing world went through a fundamental paradigm shift. And it was driven by the fact that products continue to get more complex in terms of the number of component parts and the supplier bases, yet there were no improvements in quality or efficiency. And so if you double or triple the number of component parts in something, and each part itself has no greater quality, then the overall defects per in unit continues to go up and up and up. And really, if you go back and you look at a car delivered by Detroit, so a U.S. auto manufacturer in the early 70s, if that car were delivered today, it would fail most states in the U.S.'s lemon laws, and probably similar laws here. Right? The Japanese developed a new set of principles around Kaizen and lean manufacturing that have now exploded throughout the world, and almost any manufacturer that's still in existence today has adopted those. If you think about what's in Kaizen, in lean manufacturing or Toyota Production System, is some basic things. Involve workers in the process, right? So anybody throughout an assembly line can suggest new things, quality circles. These are all terms from the 80s and early 90s from back in my consulting days, where you would get people together You would ask small work teams to look for solutions. You then empower the front line, so anyone can stop the production system. If you see a defect going through, you stop the production line, empowering people throughout the system. And you focus on continuous small improvements. So the quality initiatives, continuous improvement, the things, again, that all the major manufacturers went through in the 80s and early 90s, have fundamentally changed the quality level of finished products today. To the point now, when Sony delivers a TV and you take it out of a box at home and plug it in, it's the first time it's ever been turned on. Their quality is so high, they don't worry about needing to test their products, right? Don't we wish that were the case in software? If you look in technology, specifically software, the defect per 1,000 lines of code in traditional software models has not declined at all. Yet there is a literally doubling, tripling, quintupling of the number of lines of code in a typical piece of software, which means you're getting slower performance, significantly more buggy code. And a key reason that, that you see for the end benefits of the dramatic declines in underlying hardware performance are that they're eaten up by bloated software and errors and problems in the software. And so the software industry needs to and must go through a transformation in the same way that manufacturing has gone through that. That same manufacturing has gone through hardware manufacturing, needs to happen in software. And open source, when you think about what open source does, it is a very similar set of principles applied to developing source code. Everyone through the process is involved in the process. The source code's open. From the developers to the testers to the end customers can all see the code. They can suggest solutions. They can post it and involve their own solutions. Supply chain, another kind of major innovation of Toyota, is involved all your upstream suppliers in the process. Think about Linux. Intel enables their own hardware. IBM enables their own hardware. Oracle makes changes to make their databases run better, right? The entire supply chain is involved in creating this software. And so by breaking down this, this divide between source code and binary code, and allowing the source code to be seen, you are just allowing for continuous improvement. You're allowing for the entire supply chain to be involved. You're allowing for employee engagement, the equivalence of quality circles being, project teams on specific components of the kernel. Open source software delivers better software. There are studies around it. The defects per 1,000 lines of code, the speed with which feature functionality is added. It is the equivalent of Kaizen for software manufacturing. And in the same way that it took 20 or 30 years before the Japanese production, or the Toyota production system is another name for Kaizen, to explode across the rest of manufacturing around the world, we will see the same thing with open source and software being adopted more and more. And there are studies to show that that more and more major companies are adopting open source principles. And I think Gartner says that over half of all software will have open source components by the year, I think it's 2012, to get the exact number around that. So first off, we need to have a better way to develop software, and that is open source. The second driver, absolutely in my mind, and I've seen this over the last 2 years as we've talked to customers, of why we don't see more in benefit falling to customers of these dramatic drops on hardware prices and increases in performance, is the fundamental business models of typical software companies is broken. This idea of you pay for a license, you use that software for a period of time, 2 to 3 years, and then you are forced to upgrade because the old version stops being supported. And this kind of 3 to 4 year upgrade cycle just doesn't keep pace with what customers need or the pace of hardware. Because what happens if you think about, I call this the death of version 2.0 of software. The typical software development model, you put in a piece of software, and I'll pick your poison, a financial system, an ERP, whatever that might be. And you then start and you say, okay, I'm going to start a year later collecting requirements, right? and you get your 800, 900 requirements. That takes you about another year. You then say, okay, let me start planning out this next version of my piece of software. And you start winning down the requirements, you do planning, you start actually development. Another 18 months go by. Now let's be realistic, like any project, you take the 800 requirements and you have to downscale them to 400 because they're not all getting done. You got another year in development, you then get in development and test, and it's often 7, 8 years between versions of pieces of software. Now, when I talk to business executives, and certainly when I talk to CIOs who are talking to their business executives, business can't wait in those cycles anymore. Business moves too fast. Technology needs to keep up. And so that model of, let me sell you a piece of software, years later I'm going to develop a new version that I'm going to sell you, that you're going to implement and test, and you're in 3, 4, 5 year cycles, and some pieces of software 7 or 8 year cycles, just is not keeping pace with business now.